This is a selection of amount of substance multiple choice questions from AQA A-level chemistry past papers. This is the 11th set. Most of them have got 5 questions in. I'm going to recommend you pause on each one and then you can go through and review your answers. So with that in mind, here's the first question. And we can see here we've got a volume of carbon dioxide that we're measuring. We've been given a temperature, a pressure, and we've got a number of moles of sodium hydrogen carbonate. Now, there are a couple of things to consider here. We know the moles of sodium hydrogen carbonate. We need to know the moles of carbon dioxide. So we go to our equation. 2 moles of sodium hydrogen carbonate makes 1 mole of carbon dioxide. So my 0.05 will make 0.025 moles of carbon dioxide. With that in mind, I can now take my ideal gas equation, rearrange it to make V the subject, and now I can start to substitute all of my information in. I've got my pressure, I've got my number of moles. R hasn't been provided but will be on newer questions, 8.31, and the temperature 298 K. I now need to consider which of those need to be converted, and I certainly need to change pressure to pascals. The rest of them are actually okay, so I can substitute those in to find my volume. And I get my volume of 0.000613, but that is in meters cubed. So what I then need to do is convert that into appropriate units, and what we find from the correct answers here is going to be A or C. That number of meters cubed is actually 613 centimeters cubed. Correct answer is A. Have a look at the next question. And on this one, we have got magnesium hydroxide dissolving in solution. We've got lots of information on this. So let's try and break that down. I have a mass of magnesium hydroxide. I can find its MR using the periodic table, 58.3, and I've been told my volume is 10 decimeters cubed. Now, once I've separated out that information, I can see that with an M and an MR, I can work out N. And this very neatly comes out as exactly 0.002 moles. I've now got N and I've got V, which means I can work out C. I do my 0.002 divided by 10. It gives me 2 by 10 to the power of -4. That's in moles per decimeter cubed. Correct answer, D. On to the next question. Quite an unusual question here. And so we can't do the full calculation, but we can get close to. What we don't have here is the actual mass. But let's take a look at what we can do. My sodium fluoride would break down into 1 Na plus ion and 1 F minus ion. That means there's a 1-to-1 ratio of NaF to F minus. And that means that if I've got 2.2 by 10 to the minus 3 moles of sodium fluoride, I've got 2.2 by 10 to the minus 3 moles of F minus. So that's my N. Now, if I then look at the equation that I'm working with, M is N times MR. Well, I've got my number of moles, and I am going to multiply that by 19/42. I want this as a ratio of how much of the NaF comes from the F, because that 19 out of 42 will be 19/42s of the total mass. So when I put all of those in, I've now done it for 1 pill, going to multiply by 100 to get to 100 pills. Next question. And on here, smallest percentage by mass of oxygen. So we're going to do what's the MR of oxygen divided by what's the MR of the total compound. And I've got all 4 of those here. The first one is 16/60. This is 16/61. Third is 16/60.1. And the fourth is 32/118. Rather than do all of the calculations, let's see if we can get some comparison. This is equal to 16/59. I can then simply compare those fractions and I can see 16/61 is the smallest percentage that we would get. Correct answer is B. That takes us to the end of this video. Thank you for listening and goodbye.